Good day, everyone. My name is Hitan Anand Samtani, and today we're going to be going over everything we learned in fundamentals of telecommunications so far. So I think we should get started. Let's jump right in. Fundamentals of telecommunications. Mathematical framework and models of telecommunication. Signal processing, signal theory, and waveform properties. Principles of voice and data communications. Frequency domain representations of signals and systems. Frequency domain, the analysis of mathematical functions / signals in frequency instead of time. Advantages, it simplifies the mathematical analysis of a system. It changes the description from time domain to frequency domain, changing the equations from differential equations to algebraic equations, simplifying the equation. It can give a quite intuitive understanding of the qualitative behavior of the system. Signal compression. This is the use of various techniques to increase the quantity or quality of the signal parameters which are transmitted through any given telecommunications channel. Random signals and stochastic processes. Stochastic signal. It is used to describe a non-deterministic signal. In example, a signal with any kind of uncertainty. Random signal. It is the same thing as a stochastic signal, but it has a complete uncertainty as it is random. Properties of communication systems. TCP/IP, which is Transmission Control Protocol / Internet Protocol. The basic communication language and or protocol of the Internet. It can be used as communications protocol in private networks. HTTP, or Hypertext Transfer Protocol, is a set of rules for exchanging files such as images, text, audio, and multimedia files on the World Wide Web. It is also an application protocol. FTP, File Transfer Protocol. This standard Internet protocol is the simplest way to exchange files among computers that have access to the Internet. SMPT, Simple Mail Transfer Protocol, used for receiving and sending electronic mails on the Internet. It is also a TCP/IP protocol. Heaviside condition / distortionless condition. The criteria that an electric transmission line has to meet so that there is no distortion of a transmitted signal. VoIP, a technology which allows you to make voice calls. Instead of a regular phone line, a broadband internet connection is used. VoIP facilities change human speech to digital signals transmitted through an internet connection. When you call any ordinary phone number, the signal sent converts to a regular telephone signal before it reaches the received end. It allows you to make calls directly from any computer, a VoIP device, or a phone connected to an adapter. Advantages / disadvantages of using VoIP. Pros of VoIP. Some facets of VoIP aren't accessible in ordinary phones. You avoid paying the normal cost of using a phone line. International calls are easier to place than a regular phone line. Cons of VoIP. They don't work during blackouts. They don't connect you to emergency services, 911, 311, 011, etc. They may not assist you with giving directory / wide page listings. Modem, modulator, demodulator. A device which converts data into a suitable format that a transmission medium needs to transmit data from one computer to another. Carrier waves, a waveform modified with information-bearing signals so that it conveys information. It has a higher frequency than the input signal has. The carrier is usually used to either transmit the info via many signals at different frequencies to share a transmission medium via frequency division multiplexing. The term originated in radio communication, where the carrier wave creates the radio wave which carry the information via modulation process through the air from the transmitter to the receiver. Modem usage of carrier waves. A modem modifies carrier signals to encode the information for transmission, then proceeds to unmodify the signals, then decode the transmitted data. The objective is to create a signal that can be relayed easily, that is properly decoded. The original data is reproduced. Analog, digital, analog converters. Analog to digital converters. These translate analog signals for the usage of data processing. These data converters permit reliability and accuracy of conversion performance in a range of applications, being communications, energy, instrumentation, and measurement, as well as industrial usage of motor and power control. Now, I state here that these are two different Creative Commons images overlaid one another. This is the image in the background, and this is the image in the foreground. Analog, digital, analog, continued. Names for a digital to analog converter: DAC, D/A, D to A, or D to A. A digital to analog converter is a system that converts a digital signal to an analog signal. An analog to digital converter, also known as ADC, is literally the reverse. The process is the same, but digital signal input through an A/D converter and outputs an analog signal. So here we have on one end an analog to digital converter and digital to analog converter. They convert sound through analog electrical voltage to binary data. And on the other hand, we have binary data converted to electrical voltage through like a speaker / subwoofer and transmit sound waves. Sampling, quantization, and encoding. Sampling is also commonly referred to as signal processing. It is a process of the measurement of instantaneous values of signal, continuous in time, in a form that is discrete. A practical example of sampling is a continuous signal such as a sound wave to a sequence of samples. That is a time signal which is discrete in form. Quantization is a process of converting a signal which is sampled, discrete in time, yet continuous in value. Encoding, source encoding, line encoding, and pulse shaping. Source encoding. As it is seen in analog to digital conversion, any telecommunications medium which is available has a capacity for data transmission which is limited. Said capacity is typically measured by the factor that is bandwidth. In other words, to limit the amount of redundant bits of information, to decrease the bandwidth. Line coding. They are patterns of photons or voltage and or current that are used to signify digital data that which is conducted through a transmission line. In data storage systems, this collection of these patterns is typically called as constrained code. Example of line coding is unipolar encoding. Voltage that is positive is 1 and no volts represents a binary 0. It directly encodes the binary sequence / bit stream and is comparable to on-off keying, that is in modulation. Pulse shaping is a process of changing the waveform of transmitted pulses. Its purpose is to make the transmitted signal suited to the communication channel by limiting the bandwidth of the transmission. Pulse shaping commonly occurs after the modulation and line coding. Match filter. Match filter is obtained through correlating a known delayed signal alongside an unknown signal to detect the presence of the delayed signal in the unknown signal. A known signal is sent. The reflected signal is inspected for elements of the original signal sent. Match filter is used in detection systems such as radar. We have one such representation of radar on the bottom left. One form of the match filter is pulse compression, named for the impulse response corresponding to the input signals. Here we have an example of pulse compression, a form of match filter. Here are my sources, my bibliography, and as you can see here. And now I have to state this, iterate this. Images used. Creative Commons. Quote, Creative Commons is an American non-profit organization devoted to expanding the range of creative works available for others to build upon legally and to share. The organization has released several copyright licenses known as Creative Commons licenses free of charge to the public. This is taken directly from Wikipedia on a Google search knowledge panel that is usually on the left hand corner whenever you search for something specific. Their website is in the hyperlink I have there, creativecommons.org. I took all images from Bing image search using Creative Commons filter using a feature of Microsoft Office, insert pictures. Here in PowerPoint, I've used the same feature. This is a Creative Commons logo. On every slide that I have used with picture, I've always used the Creative Commons logo on the bottom right corner. Here's my source for the quote that I have here for Wikipedia. And to wrap this up, I'm going to end the presentation here. Hope you liked my review of everything that was in this presentation to inform you about telecommunications. I hope you guys have a wonderful day, and thank you. Peace.